Welcome students to this session related to C chart. In last session, we have started the preparation of the chart for the attributes, and in last session we prepared a P chart. So in this session, we are continuing our journey to prepare the control chart for the attribute, and the second type of chart under this title is C chart. Now when to prepare the C chart? It is used only when the number of occurrence per unit of measure can be counted. Non-occurrence cannot be counted, such as scratches, chips, dents, or the errors per item can be countable items. So if the scratches or chips or dents or errors kind of thing are to be calculated, then the C chart can be prepared. Cracks or faults per unit of distance, then breaks or tears per unit of area, bacteria or pollutants per unit of volume, false complaints, failures per unit of item. If such kind of measurements are available, then the C chart can be prepared. Now, if we need to prepare any control chart, we will require the mean line, that is called as the C bar, and the UCL and LCL, the upper control limit and lower control limit. Okay, so over here also, same as the P chart, C bar also can be found out by number of defects per number of samples. So after finding out the C bar value, the UCL upper control limit can be found out as the equation of equal to C plus Z under root C, and lower limit can be found out by C minus Z under root C. To understand the preparation of the C chart, let us go through one of the example. The example says us that rolls of coiled wire are monitored using a C chart. 18 rolls have been examined. It means that the number of samples are 18. And the number of defects per roll has been recorded in the following table. So in each sample, in each roll, the number of defects has been found out. Is the process in control? It is to be decided by using the C chart. Plot the values on a control chart using 3 standard deviation control limits. It means that 3 standard deviation means that the Z is equal to 3. So the value of Z has been given to you as a 3. Now if we see the data given below, total number of samples are 18, starting from 1 to 6, 7 to 12, and 13 to 18. And the number of defects have been identified in each sample. So sample number 1 has 3 defects. Same way sample number 4 has 5 defects. And likewise, sample number 14 has 4 defects, and sample number 18 has 1 defect. So total number of defect is the summation of number of defects for each sample. So that total number of defect is 45. Now let us find out the C bar and the upper control limit for C bar and lower control limit for C bar. So the equation of C bar, that was number of defects divided by number of samples. So number of defect, total number of defect is 45 over here, and total number of samples are 18 over here. So C bar can be found out as 45 divided by 18, that is equal to 2.5. Now the UCL is nothing but C bar, that is the mean line, plus Z into under root C bar. So if we will put all the values over here, the UCL for the C chart will be 7.24, and LCL for the C chart will be minus 2.24. But as we understood, the defects cannot be less than 0. Okay, so that we are considering the LCL as 0 instead of minus 2.24. the number of defects cannot be less than 0. So as per the equation, we are achieving it minus, but as per the practical things, the LCL cannot be 0 in this case. So LCL cannot be negative in this case. So LCL has been considered as 0. Okay. So the zero horizontal line will be working as a LCL over here, and UCL is equal to 7.24, and the mean line, that is nothing but the C bar line, it is drawn at 2.5. On x-axis, the sample number have been taken, and on y-axis, the defects per unit has been taken. So after plotting the C bar or the mean line, UCL line, and the LCL line, we will be plotting all these number of defects for each sample on this graph, on this chart. So likewise, all these points which have been shown over here with the orange dots have been plotted, and it is found that all the data points, all the number of defects points are within the limit between the LCL and UCL. No point crosses either the UCL or the LCL. It means that this particular process is under control. Likewise, the C chart can be prepared. Now, till now, we have understood the meaning of control chart. Apart from that, we also went through the different types of the control charts. Basically, two types of control charts are there: control charts for variables and control charts for attributes. For the control charts of variables, we have prepared X bar chart and R chart. And for control charts of attributes, we have understood how to prepare the P chart and C chart. So this was the lesson related to the control charts and how to prepare them. Thank you.